Good morning, good afternoon, good evening, everybody, and welcome to this Secure Guardrails workshop series. This is a series where we're going to talk about how to incorporate secure guardrails into your application security program using the context of a specific vulnerability class. Today our focus is going to be XML external entity injection. So let's get started with an exciting session around XML, Java, and Semgrep. Just to introduce your host today, I am Nitin Nair. I'm a senior solutions engineer based out of London, and I work with our EMEA customers. I've been with Semgrep for 2 years now, and I've worked across different software companies before that for almost 20 years. And we are very lucky today to be joined by my wonderful colleague, Sebas, who's a senior customer success engineer. He's based out of Spain. Sebas, in his free time, likes to onboard repos on GitLab and Bitbucket and Azure DevOps. Jokes aside, Sebas is going to be helping us out with the chat today. So I highly encourage you, if you have any questions or comments, please feel free to throw them in the chat, and Sebas is going to be there giving you some love there. So with that, let's get started. So we've got an action-packed agenda for today. I hope you find this very, very exciting. So we're going to start a little bit by talking about secure guardrails. What are they? How do they work? And then talking about how our different customers, SMEs, mid-market customers, large enterprises, very large FANG-style companies are actually using a strategic approach to roll out secure guardrails. We'll then specifically look at composing some Semgrep rules to eliminate XXC-style attacks with Semgrep. We then go talk about how do we enforce these guardrails using Semgrep code, with a focus on two things. One is how to fix issues today, but also a second being how do we prevent issues proactively from tomorrow. So kind of the reactive fix issues today and that. And then I'm going to share some examples, resources, and we can have a Q&A as we go through the session as well. Yeah. All right. So just a little bit about Semgrep. So who is Semgrep? Semgrep, we are an AppSec platform. We offer static analysis, software composition analysis, and secrets detections. And our aim is to significantly enhance the software security and reliability. We believe at the crux of this mission is we believe that security teams are under-resourced, they are understaffed, and at the same time, the speed of development is increasing exponentially, especially with tools like ChatGPT and Copilots. And the best way Semgrep can actually drive meaningful improvements to any AppSec team is to help scale their security efforts effectively. So it's all about scaling. You cannot be doing things one by one. It's all about scaling. And one of the areas where we've seen that is key to the scalability and scaling security lies in the concept of secure guardrails. And we've seen this rolled out across some of the large, big FANG companies. We've seen this in large enterprises, mid-market, and SMEs. So whatever your organization might be, whatever size you might be, there is a solution here to effectively scale out your security with Semgrep. And hopefully you see that today in the session. Before we jump into secure defaults and secure guardrails, I do think it's important to contextualize secure guardrails in the context of another application security buzzword, which is shift left, right? Shift left as a movement made a lot of sense as a backlash to the reactive role that security testing was having. And, things were getting found very late in the development process, maybe sometimes even when you're going into production, and that had a big impact on the business. Now, every security tool, even your granddad's old legacy static analysis tool can help you with some amount of shift left, right? There could be some stuff they're doing at build time. They could be doing something at pull request, or, some sort of linting or minimal scanning in the IDE. But if we look back at the last few years, and we look back at the impact shift left has had, the impact, the legacy it's left behind, we can recognize that even though the intentions behind shift left were great and it sounded great, it hasn't really effectively delivered the outcomes that people were looking for, right? And there's a myriad of reasons for that. I think there's a few reasons for that. The first one was there was a misalignment in the incentives, right? Developers are incentivized to ship features quickly. They are incentivized to make releases happen as quick as possible. And what doesn't help is when an AppSec team stands there throwing alerts like a fire hose in their mouth, and with complicated security lingo behind it, and saying, hey, can you go triage this? Can you go fix this? Hey, read this 25-page white paper on how SQL injection or XXC attacks work. That is not the right way to motivate them, and it doesn't align with their incentives. The second one is expertise. Now, finally, security issues are bugs. And I've been a developer myself early on in my career. I work with lots of developers, and I know no developer in the world wants to write buggy code. No developer in the world wants to write insecure code. But what has happened is, especially with the pace at which code is being developed and the complexities which are coming in from the ecosystem perspective, writing secure code is not as easy. It is difficult. Sometimes developers don't have the training. Sometimes they don't have the background to recognize insecure code, let alone fix it. And one of the areas where we, as an AppSec community, has failed is to make it more accessible. We need to create like the Apple iPhone version of vulnerabilities, right, for them. And we are still stuck in the Linux mode, I guess. And the third area which is there is the concept of noise, tooling, perceived noise, false positives, context switching. The whole idea behind putting an automated tool for SaaS, for example, is to be productivity enhancing for developers. And they should help them identify issues quickly. But oftentimes what happened is, as soon as you switch on a scan, you've just switched on a fire hose of issues. And depending on your tool, they may not even, you're getting tons of issues. There might be false positives, and you might also need to context switch between whatever static analysis tool you're using and where you're putting your code. So you're in GitHub, and then you go into your static analysis code, GitHub, back. And the outcome is, all of this is, even though developers are seeing things sooner, they're seeing it faster, but they're getting a lot of alert fatigue. They're not being encouraged to find fixes. So they're being told what's wrong, but they're not being told how to fix it easily. And this is leading to poor experience, mental overload, cognitive overload for them, and poor outcomes from a security perspective, where we are not able to deliver the outcome we wanted to the business, right? Where a shift left started. And so this is where secure guardrails becomes an interesting way to solve this, right? So what we've learned from the previous discussion is, it's not enough to just get the findings in front of the developers early on. That's not what the idea is. That's not what we're trying to do. The security, we need to almost treat our developers as customers, right? We need to give them those findings in a way like we would have actually served a product to a customer. Secondly, we want to, what does that mean? What it means is that developers should be seeing tailored, actionable, project-specific stuff that they like, and not just a list of things in an Excel sheet saying, go fix this. There has to be the context. And also what we need to do is make it easy for the developers to fix those issues with as little cognitive overhead as possible, as little thinking that they need, right? Make it as easy, make the fixes there, give them the context of the application, explain to them in the context of the application how the fix would work. And this green box that you see here, this is the hard part, the relevant, actionable, easy fixes, right? And so this is where the secure guardrails comes in. Secure guardrails as a paradigm is a paradigm where we nudge the developers to choose the secure option when coding, right? So instead of, if they have this fork in the road when they're making a decision, insecure and secure, we just make it as easy as possible for them to choose the secure coding. Here's a way, make it really easy for them to say, hey, this is the secure way of doing things. This is the easy, insecure way of doing things. And it's an easy decision to choose the secure way. We're not just telling them, hey, this is the secure way. We actually pave that path for them. This is the secure way. This is the secure option. This is how to make it, do it. This is how to fix it. Just make it easy for them to do it. And this is where I think shift left failed, and secure guardrails can be your biggest friend. Yeah. So with that little bit of background, let's go into talking a little bit about the strategic approach to guardrails. I'm just going to pause here also and see if you guys have any questions. Feel free to drop them in the chat. We do have Sebastian on the chat, so feel free to put them here and he's going to answer those questions. So please feel free to use the chat window there on the in your screen. Yeah. Thank you, Sebas. So let's talk a little bit about how different organizations look at secure guardrails. And I mentioned, we've seen this secure guardrails rolled out at SMEs, at mid-market customers, the whole concept of an AppSec team of one. We've seen these rolled out at large enterprise customers, some of the largest tech companies. And there's a couple of different approaches that you can take, right? So firstly, by default with Semgrep, we do have secure guardrails built into the platform. So even if you don't do anything, even if you just start scanning with Semgrep, secure guardrails are already built into the platform. And I'll show you a couple of rules around how we do that today in context of XXE. But then what you can also do is, as an organization, you can take a targeted approach and be really intentional and strategic about if there's specific vulnerability classes that are important to your organization. And these could be for different myriad of reasons. So let's actually look at both the second approach now in context of our session today. So we're going to meet Riley here, right? Riley is an application security manager. He works for a fintech called Acme Corp. And Acme Corp, actually, as part of the services that they provide to their end customers, work a lot with many of the large financial services counterparties. So big banks, stock markets, brokers, etc. And because of the legacy, most of the conversation or communication between these organizations and Acme Corp is done using XML. And at Capital Gains Group is done using XML. And what they've seen is in recent times, there's been a rise in XXE injection issues. Also, when Capital Gains Group did audit an internal risk assessment as part of their DORA, DORA Act, which is coming into play in Europe in 2025, this XML and XXE injection was identified as a high risk. So let's do this today. Over the next half an hour, we'll work together to actually create a plan. We'll write some custom rules. We'll look at how we enforce those custom rules in IDE, in PR comments, using Semgrep memories, etc. as well. So sounds like a good plan? Yeah? All right. So what are the typical steps that you would take? So that, putting Riley aside, now when you as an organization are looking at secure guardrails, etc., there are two approaches you can take, right? You can select a vulnerability class. And to do that, there's a couple of approaches you can take. One is, like Riley, you can take an approach around what is the biggest risk to your organization. And this could be based on previous experiences. It could be based on some of the upcoming regulations like DORA or NIS2 that you might be looking to comply with, right? The second thing you can do is you can look at recurring vulnerabilities that your team is spending time on, right? So these could be vulnerabilities that keep popping up again and again, and the dev teams are spending a significant amount of time on fixing these issues, but it's recurring. It's like a common theme. And, if you look at your rework rate for some of these teams, there's 5, 10, 15% being focused on this vulnerability class. It also becomes like a big distraction for your developers. It's eating into your support budgets, etc. So it could be that you could then look at some of these recurring things, eliminate these distractions, and get your developers focused on these. So let's pause here. And I'd love for the audience to actually maybe share in the chat if there's any vulnerability classes that come to mind, or any thoughts around what those vulnerability classes might be based on the two approaches that you have. So feel free to pop them in the chat here. Sebas, any that come to your mind that you want to maybe pop in the chat for good examples of secure guardrails? Brilliant. Thank you, Sebas. And so once you have identified that vulnerability class, we then validate it by writing a simple guardrails rule. So that's what we're going to do today for the XML injection, just to show how it works, how it goes. We then talk a little bit about how we can partner with our engineering teams to design a secure default. And then we look at how we enforce those custom guardrails and secure defaults in our PR comments as part of our SDLC, as part of our IDs, etc. And then last but not least, measure the adoption. Yeah. So it's an interesting question. And right, you might say, hey, we talked about Riley, but I still want to go into a little bit more detail around why we chose to prioritize XML, XXE injection, right? And I think the biggest reason why Riley chose this is the applications, the services, the components that he works with. They process a lot of XML, and in his case, these applications are high-value targets. And what we mean by high-value targets is these are public-facing applications. These are highly visible. They're working with highly sensitive data, and this could be kind of PII. It could be financial data. It could be data which is governed by regulation, etc. So that's one key area. Second is at the capital gains group, they do have a very segregated, isolated, trusted network. And what is happening now is through this, we are essentially giving them access through an XXE injection, external resources. Also, some of the code in the capital gains group is pretty old. It's coming from legacy systems, IBM mainframes, etc., with custom XML parser that were written maybe a decade or a few decades ago. So they don't always have the best security built in just based on the time, and they haven't been updated. And then finally is in the case of capital gains group, there's a lot of user supplied XML data which is coming in from their counterparties, from their third parties, etc. Yeah. So Java is the main language. So what we'll do now is maybe jump a little bit into an XXE injection attack, and we'll also look at Java, how Java handles XML. Yeah. So starting off, what is a XML external entity injection attack? So what happens in this case is when an XML parses a malicious XML payload, right? So this is a payload which is coming from a third party, from a user. And then in this payload, the attacker has inserted a reference to some external content, right? So this could be a call, could be a file, what have you, which has been added there. And now during the parsing, the parser will essentially dereference this payload. And when they dereference this payload, really, really bad stuff can happen. And, some examples could be retrieval of sensitive data. So you're now inside my trusted environment. You may not have all the firewalling or all the network segregation. So now I have access to sensitive data because I'm part of inside. Communications with internal systems. Again, trusted environment, you may not be doing all the firewalling, etc., that you need, and you now have access to internal communications, and then arbitrary storage of code for future execution. And to be honest, sky's the limit. It just depends on how evil you want to be, but this is a very, very serious impact. With that background overview of what XXE attacks are, and now that we understand they can have a very serious impact on the organization, you would think Java would make it really easy for your developers to do the secure thing, to parse and process XML in an easy, secure, in an easy way, in a default way. Well, let's see. Now, my colleagues Peter and Vasily actually did research on the XML parser landscape in Java. There's a link to the cheat sheet here, which they've written. Highly recommend. It's really good. And the Java XML parsing landscape is an absolute mess. There is multiple different interfaces, DOM, SAX, XSLT, I think maybe another 18, 20 more. There's multiple classes for each of these. So DOM uses document builder factory, SAX uses schema factory, etc. Right? And there's 10 methods to reference external content in XML. Now, each of these classes has different security features to protect these methods. And by default, these are not enabled. Now, take a minute to understand that. So if you have an application where you're using multiple classes and multiple interfaces, you now as a developer will need to have the mind space. You need to think about it. You need to spend the time to actually say, hey, I'm using this document builder factory. This is how I secure it. SAX reader, this is how I secure it. It's not easy, right? And what do the developers do then? They just default to doing the easy thing. And by default, unfortunately, Java is insecure. So today what we'll do is, just to keep the session scoped, we're going to focus on the document builder factory class, which is a part of the DOM interface. The principles I'll walk you through would be directly applicable to what you are seeing here. The principles you see here will be applicable to the other classes and interfaces as well. And Sebastian just posted the link here, so feel free to actually use those as future reference as well. And if you have any questions, feel free to reach out to us. Yeah. So let's get started here. Before we jump into writing a rule for XXE, now that we understand what an XXE injection looks like and what the Java XML parser ecosystem looks like, let's look at the million-dollar question, right? You might come and say, hey, Nathan, we've had SaaS tools for decades now that do XXE injection. What's the difference between a vulnerability detection rule that I see with a typical SaaS solution, including Semgrep, and a secure guardrail, right? So at a high level, a secure guardrail is a kind of rule that helps you write secure code, and it discourages you from writing an insecure code. So why is that good? It's a proactive approach to scanning, right? So it's saying, hey, don't do this because this can be today be insecure, but also in the future, depending on how your code grows and matures and how people add additional data, it becomes this, right? Now let's compare that to an old school SaaS tool, which is reactive, right? So what an old school SaaS tool will do is it will look at XML parser, right? And then it's going to use the data flow or taint propagation to say, hey, how is the data flowing through my system, right? And it'll check for essentially orange paths like this. Now, that's great because maybe when the code was written and when you ran the scan and when you inserted this XML parser with the insecure configuration, there was no user data coming in here. So it's great, right? You could catch things and it was okay. The problem happens is when it is not detecting some of these other paths which still do not have user data, right? So today when we wrote the rule and we ran the scan, you removed this path and it's secure. But let's say tomorrow, my developers add additional things, they add additional capability. And at that point in time, we actually insert a path here coming in from this side now, going into my XML parser. Now, this will make it insecure. And this also shows why traditional vulnerability detection is kind of more like a reactive way, because what you did is you only check for, hey, when I wrote the code, was there a user data or there's a taint there? But it does not protect against futures, right? And so this is where Secure Guardrails comes in. And what Secure Guardrails says is, hey, from the start itself, there is no reason to use an XML parser which is insecure. So whenever you write an XML parser, you start with a secure way. It's a more proactive approach because independent of how your application grows and how people add additional code and functionality, it will always remain secure. Lots of times it might be that the dev or the team who added the XML parser may not be the same team who was actually creating additional user flows because they just assume some of this capability is there. And now you're showing them this and they're like, oh, I don't know what to do with the XML parser because I've detected it in a reactive way. So proactively, you're telling your backend team who's working with the XML parsers, who are making the calls to those third-party counterparties to say, hey, we will not use insecure code. It's proactive. It does not require a crazy ton of analysis. So as a developer, I'm not trying to say, hey, is there a path there or not there? Am I sanitizing it in any way or not? There is no cognitive overload. It's really, really simple. It's a simple question. Hey, is this XML parser secure or insecure? If the answer is insecure, let's fix it. And let's make the whole structure solid, right? So that's the idea behind Secure Guardrails, providing simple guidance to steer developers to make security choices and to prevent vulnerabilities from arising, not just today, but also in the future. So with that, we now have, so now let's actually get into the fun part, and we're going to go write some custom rules that all our audience always likes. So we're going to do that now. So let's get started, right? So we have two ways in which we can see if our XML parsers are insecurely configured. And what we're going to do is we're going to write secure guardrails for both of those. The first one is, we're going to start one. It's a very simple one where a security feature has been set to an insecure value by the developer. And the second guardrail that we look at is a little bit more complex, because we look at things like missing configurations, and then we have to take all that analysis that Vasily and Peter did to understand when is the default secure, insecure, etc., and also writing some auto fixes for them. So let's get started. Just at a high level, we talked about it in terms of the messiness of the XML parser ecosystem in Java. But what you see here is some of the research that Peter and Vasily did. What they did is they actually looked at 10 different classes in Java for handling XML. So you can see, our document builder factory, which comes from DOM. And then they also looked at the different configurations. So the default configuration that these classes have, you have the feature secure processing, etc. And then what they did is, hey, out of the box, how many attack payloads is this vulnerable to? So if we look at specifically around the document builder class here, you look at document builder, you can see here that in the default configuration, it is actually susceptible to 4 payloads insecurely, right? Same thing with the SAX parser factory. By default, with the default configuration, it will parse 4 types of attack payloads in an insecure way, right? Really, really bad things happen. If we now look at the feature secure processing, which is one of the things we look at in our demo, in our rule writing, we see that once we enable this, you can now see the document builder factory and SAX parse factory are all down to 0, which is really good. But here is the messiness, right? If now at a later date, one of your developers decides to put SAX builder or SAX parser, this feature secure processing is not going to help them. And that's the messiness. That's the cognitive overload that the developers have to do. They have to now go look at research like this. And XXC is just one type of attack vectors they might have, and then make up their decision. So this is where we as an AppSec team have the ability to maybe help them, make things easy for them. Yeah. So now let's jump into a very simple rule. We can do it one of two ways. We can either, maybe I'll ask you guys for any ideas, etc. So feel free to put them in the chat and I can read them out. So the first rule here is really simple. Let me just walk you through this and hide the answer. So I have this, it's a secure guardrail. And what we're trying to do here is find an insecure configuration. So what I have here is I've got this class called bad document builder factory. And in this, I have this method called bad XML input factory. I create instance of the document builder factory here, DBF. And what I'm doing is on this DBF, I'm setting a feature called external parameter entity equal to true. This will make it, of course, as we know, insecure. Similar thing here. I've got the SAX parse factory, and on this, I set a feature equal to true. So these are bad. So what we need to do is write a rule which catches these two, but does not catch this two, because in this case, I've got the good factory, and here what I'm doing is I'm setting the feature to false. So any ideas around how we would start writing this rule? Love to get some thoughts before I'll give everybody maybe 30 seconds, and then I'll go into the solution. All right, so let's get started here. And let me just walk you through the rule here. So this is like a typical Semgrep rule that everybody is aware of. We have an ID here. This could be anything you choose. The language, the metadata, etc. The rules are, as you can see, written in YAML. But the most important part of the rule is this thing called the pattern, right? And what the pattern is doing is the pattern is typically written in the same language as the code. So here you can see it looks similar to Java, with certain additional attributes like or concepts like meta variables, etc. And so here what you can see is in this rule, I've written a really simple rule. I'm saying, hey, a $XML is a meta variable, and this will catch any element of type document builder factory or Sax parser factory. And it's checking, hey, whenever for this, this object, I set the attribute external party equal to true, that's bad. Really simple rule. So what we're doing here is this, and we're catching on this. Makes sense, right? Really easy. And then what we're doing is we have this capability called fix. And what this fix does is it will catch this, and then it will replace the pattern we caught with this fixed one. And it's a really simple fix here, because all we're saying is, hey, wherever this is true, just go set this to false. So actually, let's run this now. And so here you can see now that I am catching on these two here. So I'm catching on line number 11 and 14. And we also have this message here going, hey, this vulnerability and how to fix this. Yeah. And then to see how the fix works, I'm actually going to open up my IDE. So I have my Visual Studio Code here, and I'm going to actually create a file which has an insecure Java config, right? So let's go here and go ahead and add a new file, this. And in this new file, I'm going to add some insecure code, right? So again, you can see the same thing. I've got this document builder factory. I've set this to true. I've got this Sax parser factory. Again, set this to true. And the way Semgrep scans work is they're really, really quick. So as soon as I hit save, this will actually now run the Semgrep scan. And literally within less than a second, you've got these squigglies here. So you can see here, this is catching this. This is a link to the finding. And what you can also do is if I click here, quick fix and auto apply, what this has now done is it's changed that true to false automatically. So what we've done is we've created that paved road. We've created that guardrail for your developers to very easily do things, right? In the IDE, he says, oh, it's a problem. And then he clicks on quick fix. Like, oh, this is an easy way. Same thing we can do here for this one. So again, you can see here that by default, this is true. And if I now click here, apply quick fix, brilliant, it's gone false now. And as soon as I now save this, those squigglies are gone away, right? So we now know this is fixed. Really simple, really easy for you guys to actually make this happen for your developers. Yeah. So that was a very simple rule. Let's go back to our here. Now we're going to look at the second example, right? So the first example we were looking at was, hey, security feature is insecure value, set to insecure value. Now we're going to look at misconfiguration. And this is where this will be really helpful because we have to do the research around this. So let's look at this. It is a slightly more complex rule. And what you can see in this rule now is, let me run this rule here very quickly so we can see this. Right. So you can see here, again, this is my rule. I have this class bad document builder. What I've done here is I've created a new instance, of document builder. And then what I'm doing here is I haven't set any of, so this new instance by default is insecure, and I haven't done any other configurations there. Same thing here with this one. But if you look at this third one where I have this root called do post 3, the root mapping foo, I create a document builder factory instance, but then I actually do the right thing here and I actually go and set this feature to true, right? And so here, what I've now done is I actually am not catching this because this document builder factory is really secure as well. So that's what's happening here. let's now look at the rule. Now, I will tell you one thing. So rules like this will be a little bit more complex because what we're trying to essentially do is codify this whole matrix into the rule, but that little bit of initial effort is actually making it really easy for you in the future. And by the way, the secure defaults that Semgrep ships with already has some of these rules, so you get this out of the box with Semgrep anyways, right? And so what we're doing here is we start off by looking at the pattern. The pattern is essentially a combination of some logical bear with me 1 second. So the pattern is a combination of different binary Boolean logic. So the first thing we're doing is we're going to find when a new instance is created, right? So we're actually catching on this. But then what we're saying is, hey, by the way, that's great, but it shouldn't be inside a method like do post to, where we then go and on this feature start setting up the secure features, right? So these are my negative cases, because once I do this, that means it's secure. So if I only do this, it's insecure. But if I do this with one of these, it is secure. And this is Boolean logic, right? And in some cases, so you can see here, one way to do is the disallow document declaration. You can also disable external LTDs. You have this, you have the feature secure processing that we saw here as well, right? And this one, which is our feature secure processing, which makes this DOM really, really simple and easy and secure by default. So really powerful. And in some cases, you actually might have multiple things you need to do to make it run. So really, really powerful, really, really good way you can make this, right? I'm just going to pause there. So we looked at two examples of secure guardrails. One was to see when a developer is setting something insecurely, and the second one is a little bit more complicated. But any questions, feel free to put them in the chat before we jump into the kind of how an XML XXE or XXE injection vulnerability detection rule looks like, which is the standard SaaS rule, right, where we're doing. So I'm just going to pause there. Any questions from the audience before we jump in? Brilliant. Now, so kind of now that we saw a guardrail and we saw how simple is it and how it's proactive, let's kind of contrast that with what a detection rule will look like. And we'll write the same detection rule. We'll write it in Semgrep, right? So you can compare the two. Now, the detection rule does two things. So the first thing it does is, like a secure guardrail, ensures that the XML parser is incorrectly configured, right? So we have a sync. But then we also check, hey, in the application, is there user provided data that is being used to go there, right? So we are doing that user tracking. I'm not going to spend a lot of time going through writing this whole rule from scratch. My colleague Peter has done a great job doing that. So a little bit of a homework for you guys to go look at this and play around with this. What we will do is actually look at a simpler example from a vulnerability detection, so a SaaS kind of a rule, right? And so here what you can see is the rule is doing two things. We are first actually, so let me go here. And so the first thing the rule is doing is, as you can see, I have a class here called bad document. And in this, I have a route mapping, right, path message. And in this, I actually have an input string called file, which is coming in. And this file is now being passed into my parser. And the parser is this document builder factory, new instance. And as we see here, again, there hasn't been any setting of secure parameters. So by default, this is vulnerable, right? And to do this, the way we do this is we have a mode in Semgrep called taint mode. And the way taint mode works is it will track user inputs. So things coming in through, route mappings like this. So in this case, this file string, and tracking it through the system, right? So it goes through this, and Semgrep is intelligent enough to understand how Java works, how functions are invoked, how classes work, etc. In taint mode. And so we can actually do this. We can do this. I've just made a very simple example here to just show you the process, but we can do this cross-function. We can do cross-file as well. So really, really powerful. So let's actually look at the rule here. So this is the taint mode rule. The first thing we're doing is defining a source. And the source essentially is any function here, right? So you can see the force function is here. So you've got a return variable, you've got the method name, and then you've got a request, and you've got this source, and the source is of certain type, right? And this source is now my source of taint. In the more complicated rule, the more one rule that you'll see with Semgrep, you'll actually see that we can also look at things like type being strings versus booleans versus integers, because and I know integers and booleans cannot cause injection style attacks, right? So really, really powerful. And then what I'm doing is I have a really simplified version of a sink, and the sink here is parsed or parse, right? So what is matching on this? And then we use a concept of labels here to essentially label how the taint is going, and if the taint is going through a secure path or non-secure path, and what makes so it's saying, hey, the taint is flowing here, but not through this non-secure taint label, and through the secure taint label. And what's making this label secure is the fact that the parser actually has the feature processing set up there. Really simple. Sebas can actually link in a link to taint labels, etc. But again, really, really powerful way to make this detection rule, right? Great. So now we looked at two different approaches to help out the developers, right? And what I noticed, and I'm sure you noticed as well, is neither of those two approaches were the best, right? There's still an opportunity for optimization. There's still an opportunity to make it even simpler and even easier for our developers, as we saw. And I think that the crux of the matter is, by default, none of the Java XML parsers are secure out of the box. Which means there's additional research that the developers have to do. They have to think about it. They have to make a decision. They have additional cognitive overhead for them, right? It just makes things complex. It makes things triaging, remediation, not as dev-friendly as possible. It pushes them down the path of having to learn a lot more security things, which is not a bad thing, but it's just takes time, etc. Right? So what we could do actually is partner with our developer teams, with our engineering teams, to create a secure default, right? So let's actually look at an example of a secure default here. And this is something that I've seen rolled out across small organizations, across teams with like 3-4 AppSec engineers, to large tech organizations, to kind of FANG style companies as well, right? And so here what we are doing is essentially creating a new class called Secure Document Builder. So this is something that you partner with your dev teams and say, hey, we're going to create this. And what we do is, by default in this class, we just enable all the secure features. So it's not something that the developers have to do. As soon as they create an instance of this, we already have the document builder factory. We have set the feature secure processing to true, and we've set the disallowed doc type declaration to true, right? Really, really simple, makes it really easy. And now as a developer, what can happen is, let me run the rule, right? So what you see here is, as a developer, if I'm doing the right thing, I create a document builder and I instantiate from this class the secure document builder. However, if I'm doing the wrong thing, I'm instantiating from this, right? It's really easy. Right thing, secure document builder. Wrong thing, document builder factory. We don't have to do any kind of additional thinking. It's a paved road. It's well defined, right? And what this does, it also makes my rule really simple. It says, hey, my pattern is document builder factory.new instance, and the fix is secure document builder.new instance. Really simple, really easy, right? So that's how we do it. Very, very easy, simple way in which our developers can write a secure guardrail, right? Very easy for them. And it comes with a lot of different benefits. First is, it's really easy to create and enforce guardrails. We can do this, and I'll show it to you in a second how this can be done as part of the IDE or the pull request, right? Really, really easy, shift left happening. But what makes it really easy and happen is kind of going back, because what we've done is we made it easy for them to make that decision, right? Other benefits come from a code quality perspective, like usabilities, like try, right, to do not repeat yourself, code bloat is reduced, maintainability, etc. So let's now jump into the next section where we actually enforce this with Semgrep. So for that, what I'll do is I'll maybe jump into the policy board in Semgrep. And this is really powerful because this gives you a way in which you can actually control the way your developers control the way in which your developers are actually consuming your findings. So we have 3 different modes in which a rule can be. The first mode is monitor mode, in which the findings can be shown here in the UI. So this is more like an audit style mode where you can see everything. You can see everything, but it may be a little bit noisy. The next mode is what we call comment mode. So these are rules which are high fidelity, low noise, very related to you. And for these, in addition to actually showing you the findings here in the UI, the rules will also be shown in, we'll leave a pull request comment. You could also add things like Slack notifications, etc. here as well. So let's actually now look at this same rule that we just wrote for secure guardrails in the context of a comment. So let's say this is my colleague Jason. He created a file, he added it, and by default, by mistake, he's actually, instead of using the secure document builder, he's actually used document builder factory, right? And now he gets a very, very simple reply from the Semgrep bot, and our scans tend to be very quick, typically in the order of like a couple of minutes on pull request. It says, hey, by the way, at Capital Gains Group, we do not use document builder factory. We actually recommend you to use cgg.parser.this. And you can see here that autofix that we put there in the rule. You remember this line around this autofix that we put? This is now automatically giving them the commit suggestion. And if he wants, he can just click here, commit change. And it's so easy for them to actually fix this issue. Really, really easy, really, really fix. Simple steps here. And there's also some step-by-step instructions here around this, right? So really simple, really easy in which they can fix this in the pull request comment. Let me show that same thing to you here in the IDE. So what I'm going to do now is actually create a new file called XXE defaults. Yeah, so let's create a new file here. Bear with us. New file, XXE default, and we're going to add the same stuff here. And again, you can see here, I've got this good code where I'm using secure, and this is the bad code where I'm not. And if I just click save now, as soon as I click save, literally within a couple of minutes, you see the finding has been shown here, and I can go click here on auto fix. And as soon as I apply auto fix, it's automatically being changed to secure default. And this is what we mean by secure defaults. Really simple, really easy. There is no cognitive dissonance. There is no thinking. It just works. It just makes it easy for your developers to fix things, right? So really, really powerful. We did this. The other thing you can also do with the Semgrep policy board is the third mode, which is the block mode. So with the comment mode, what happens is the comments are shown to the developers, but it does not block the PR. Now, for your very high impact, some things like this, right? Secure cookies, secure XXE, you can actually move the rule into block mode, in which case the finding would still be shown here in the UI. It would be shown in the PR comment. But what you can see here is the PR comments actually being blocked. Right, so we're actually now blocking them from doing the wrong thing till they actually fix the issue. So that's a little bit around how we enforce these in IDE and pull requests, etc., using the Semgrep cloud. What I wanted to do next is there's an additional capability that we recently introduced, which is called assistant memories. I know we've talked XML to death, so I thought I'd just kind of bring in some humor with some cookies and secure defaults, right? And so what this does is you can use our AI-powered assistant, which uses, which is kind of is our AI-powered assistant, which is based on OpenAI, to actually create personalized guardrail guidance and messaging using human language, and can also be used to specify secure defaults in an easier way. So if you don't want to write your own rules, you want to take our rules but make them custom here. So let's look at an example for that, right? So here what I've done is I went and opened a pull request, and in that pull request, what I've done is I've essentially defined a function called set cookies, and I've set it secure equal to false, right? So it's similar kind of thing where we were setting the XML properties in my document builder. So here we're doing this. This is bad, right? So by default, Semgrep will catch this, and it will kind of explain to the developers how to do this, and it will actually give them fixed suggestions, which is great. When you do this, you actually set the secure cookie flag to true. It's really helpful, really powerful. But let's say I actually am, at our organization, we use a class called, we use a middleware to automatically do this, right? So let's say, we use an internal custom response class called middleware secure cookie response, that the devs can import from the Acme security library. And we also want to make sure that the response is the default response class, right? So what we've done now is saying, hey, instead of going and doing this right now, which is you go and set cookie manually, I just want you to use my middleware cookie, secure cookie response class. And as soon as I click this, what will happen is it will actually auto-generate the fix here. And this is now what the fix looks like. So previously what was happening is the fix was asking them to set that to true. Here now what's happening is it's actually using the middleware secure cookie response class. It tells you to import the middleware secure response class from Acme security library architecture. And the way to do it would be something like this. Then you set the response class here in your app response class, and that's all you need to do. So this is what the fix now looks like. And this is now aligned with your guardrails. This is aligned with your architecture, and really easy because you haven't actually had to do any kind of changing rules, etc. So really, really powerful. If you are interested in reading more about this, I did write a blog recently that Sebas has linked into the webinar. So feel free to give this a read. It kind of goes into much more detail around this. And then the last step we wanted to do is manage and monitor how our guardrails are being optimized, being used. And to do that, we actually have the dashboard capability in Semgrep. And here what we're seeing is, hey, how many of the findings that we are fixing are actually being shown to, how many of the findings are being shown to developers? And then over time, how many of the findings are actually being fixed even before they enter my default branch, my main, my master, my develop branches, right? And for me, a good security program would be one where we start seeing the dark green, which is the number of fixed things, increasing over time. Because what's happening is we have these secure guardrails. We are making it easier for the developers to fix things. So we should see those fixed becoming bigger and bigger over time. We should see the ignored go down, because what we are doing is we are customizing the rules. We are aligning the rules to make them specific to the organization. Hence, your developer should ignore less. And open should be growing as well, because as we educate the developers, as we give them these secure defaults, they should not be doing more insecure things. So those open should go away. So really, really powerful way. I know we've talked for an hour, so I'm going to just maybe wrap up here. I've seen this deployed at different sizes of organizations. You don't have to be a Facebook or a Google or a HSBC or a big bank. The preventative mindset is great. You can do it today. I've seen this working at SMEs. I've seen this working at mid-market accounts. I've seen this in enterprise customers. I've seen this with media. I've seen this with retail. And it is possible. And it has big impact. It has big ways in which you can actually fix this. And just to kind of give you some examples there, you could create guardrails or secure defaults for specific RBAC functions have to be used before any user-facing operations or APIs are defined. Instead of allowing developers to use their own encryption libraries, you could use your custom encryption libraries, which are configured with secure defaults built in, right? Like we did with the cookie example, like we did with the XXE example, right? Prohibiting specific libraries at global scope, right? In prohibiting hard-coded secrets. Really, really, really simple, really easy ways. You don't need to be a Google or a Facebook or to be actually implementing this. You can do this now, and the impact will be really great. So hopefully you enjoyed it. I know we're running out of time, so I'm going to pause here. But any other questions, any thoughts, any questions, please let Sebas or I know in the chat. If not, thank you for your time and attention, and we'll catch up soon.